Hello, good afternoon. I hope you are having a good experience during the conference. I'm Paulo Campos, a telecommunications engineer based in Madrid. I'm passionate for open source technologies, and I really feel fortunate to live in such an exciting era with so much Linux, cloud, and DevOps spurring around. I work in Vuenext in close collaboration with the DevSecOps group of Santander Global Tech. So let's go for a quick introduction of the Istio service mesh. Why Istio? The rise of Kubernetes as a platform led to an increase of microservice deployments. Over time, that number of microservices typically grows, and the complexity of their communications grows too. Sometimes the distributed microservices can reach a complexity where it becomes difficult to understand their traffic patterns. In those moments, one might just want to have an easy management pane to handle such traffic complexities. And this is where Istio comes into the picture. Istio allows to gather insights and facilitates the understanding and management of complex network patterns. Istio focuses on three main venues: enhanced traffic management, which enables better control of traffic between the microservices, for example, enabling stage rollouts with percentage-based traffic split. On the other hand, Istio also focuses on observability, which provides easy traffic visualizations with relevant performance metrics. And Istio focuses too on security, for example, by transparently enabling mutual TLS by default for all intramesh communications, and other advanced features such as ingress, egress control policies, and access policies. Overall, Istio is like a dedicated layer for advanced network traffic management. So, about installation, Istio can be installed either via the Istio-CTL binary, or with an Istio operator, or with an Istio Helm chart. There are detailed instructions for each option in the project homepage. Configuration. Istio is configurable via YAML manifests, much like everything in Kubernetes. It introduces some new Istio CRDs, custom resource definitions, to enable advanced features, such as ingress gateway, virtual service, and others. And how does this all work? Well, basically, when a new pod is created, Istio will auto-inject into the pod a sidecar container running an Envoy proxy. The sidecar container will configure the pod networking namespace so that all the pod's network traffic is transparently intercepted via the Envoy proxy. And the Envoy proxy is controlled by Istio through a control plane. Overall, Istio manages to control the entire service mesh traffic passing through the Envoy proxies, and that is how it can introduce some new interesting traffic features, which we'll try to see next. Istio also have some tight-knit integrations or add-ons, which help augmenting Istio functionality or help to expose Istio features for the users. Basically, Istio uses Prometheus for extracting internal metrics inside of the service mesh. Then Istio uses Kiali to expose the most relevant metrics and composes quick user visualizations showing the overall traffic patterns and HTTP status. Istio also includes Grafana to dive into more detail on the extracted metrics with pre-configured dashboards for metrics per service. And finally, Istio leverages Jagger or Zipkin to collect and display end-to-end distributed tracing on the application level. Let's have a quick look at the demo. This is Kiali. Kiali is the central place to visualize traffic patterns. We are going to focus on the Kubernetes namespace called Istio demo. Let's see the version graph view. And let's display the request distribution and the beautiful traffic animations. Now let's reorganize this a little bit. Right here and there and there. Okay. So what is happening here? In Kubernetes, I've created a namespace called Istio demo with a special label that commands Istio to auto-inject within all the pods. So all the pods are controlled by Istio inside this namespace. Also inside this namespace, I've then deployed some microservices. For example, the Sidious, the Gamma, the Antares, the Vega. Each microservice of these ones is composed by a service, a normal Kubernetes service, the triangle, and a workload, which is a deployment, a normal Kubernetes deployment with multiple replicas. They are not visible, but a normal deployment. In this microservice in the Gamma, there is a Kubernetes service, but there is also an Istio resource, which is called the Istio virtual service. This Istio virtual service enables to use some of the advanced traffic features of Istio. And one that I've configured here is called percentage-based traffic split. So we have the virtual service here, and then we have two different workloads, two different deployments. Each deployment is running a different version of container images. So this is application version 1, and this is the application version 2. And then in the virtual service, I've configured so that around 90% of the traffic should be directed to the version 2, and 10% of the traffic should be directed to version 1. This can be seen here in the details of the manifest in the virtual service of Gamma. Down below, this is configured so that subset V2 will get 80% and subset V1 will get 20%. So let's change this to 90 here and to 10 here and hit save. And throughout the presentation, this will keep changing. Let's go back to the graphic. And there we go. This will change progressively as time goes by. It will converge into those values. So we have the microservices and the special Istio virtual service. On the left-hand side, we also have two traffic sources. This is the native Kubernetes Nginx ingress controller, which is not part of the service mesh. It is deployed in a different namespace. And so for the Istio service mesh, it is seen as an unknown traffic source. And then we have a new one, which is this load balancer, which is the Istio load balancer, Istio ingress gateway. It's like the Nginx ingress controller with Istio superpowers, so that the service mesh can extend all the way through until the load balancer, so that the traffic that goes into the load balancer can already be started to be shaped by the advanced traffic management features of Istio. One very interesting feature of Istio that it's enabled by default and transparently is mutual TLS. Istio enables mutual TLS between all the microservices automatically, transparently. Let's display here these black lock keys. So basically, all the pods in this namespace have an Istio envoy sidecar intercepting their traffic. When one micro creates an HTTP request, for example, when the Polaris workload, when one pod of Polaris creates an HTTP request, Istio, the sidecar, will intercept it, and it will inspect the host header. And recognize if the destination is another micro, which is also part of the Istio service mesh. In this case, Polaris is making HTTP requests to Sirius. And so the host header contains Sirius. And so Istio recognizes that Sirius is a known microservice. And so Istio will transparently create a mutual TLS session between Polaris and Sirius, between the two endpoints, and safely transmit encrypted the HTTP data between the micros. So Istio automatically handles the mutual TLS certificate creation, management, and distribution between all the micros. It does this for all the micros inside the service mesh. And this is transparent to the application running inside the pods, inside the workloads. If it is a Spring Boot or whatever application is running, the application creates an HTTP request, the application sees an HTTP response, and the application is not aware that over the wire, the communication is being sent inside an encrypted channel, encrypted with mutual TLS, so that both microservices can recognize each other and allow that traffic. In the case that traffic is coming from outside of the service mesh, for example, from the Nginx controller, then that traffic will be delivered to the service mesh without any modification, without any encryption. In the case of the load balancer for the Istio ingress gateway, that traffic is already being encrypted from the load balancer into the service mesh. So the load balancer is already part of the service mesh, and so it gets encrypted from that point on. Well, going back to Kiali, Kiali can also give us very interesting metrics and data regarding the traffic. We have these lines called the edges, where we can ask it to display the request rates, or, for example, the response times. The response times is the time between a request is made to the micro and the response is sent back for that request from the micro. It is showing us the 95th percentile. The value that shows is the 95th percentile of the response times. Also, on the right panel, Istio shows us some interesting metrics. We have quick access to those metrics, like response times and HTTP status codes. We can see here the several response codes and the metric values for the response times. This is done by microservice, by edge connection, so it's quite complete. It's quite extensive. Well, about logs. We can also go into the detail of the logs of each workload, and we can select the pods. We have here a first container, which is the container that is serving the HTTP request, the application container, and the second container, which is the Istio sidecar, the Envoy proxy sidecar. We can search through the logs using regular expressions. It's interesting. Also, Kiali provides us some charts about inbound and outbound traffic. They have many options to be explored. Well, more interesting, talking about charts, Istio comes bundled with Grafana. Grafana can go deeper and display automatically created pre-configured dashboards with metrics per service. So for each of the services, microservices that we were seeing the last in Kiali, Grafana automatically creates these dashboards without any user intervention, which is great. Finally, Istio also bundles together Jagger, which could also be Zipkin, to enable distributed tracing. Overall, Istio enables many advanced traffic features, but that comes at the cost of complexity. It is quite complex to set up and to understand, but in some cases it is worth the effort and enables a new level of operability that was not before possible. I hope this Istio introduction was interesting to you and your team. Have a good afternoon and enjoy the rest of the conference.